This is Mr. Martin. These are the Geometry Honors Notes for Section 8.4. In this video, we're going to be talking about congruence and proportions in similar triangles. So the first thing that we're going to talk about is very similar to what we did when we proved triangles congruent. Once we proved triangles congruent, we were able to use CPCTC, corresponding parts of congruent triangles are congruent, to help us prove that other segments were congruent or other angles were congruent. So this section, it's going to be similar, a little bit different for part of it, but some of it's exactly the same. So once you have proved triangles are similar, you can also conclude that corresponding sides of the triangles are proportional. Now keep in mind this word proportional, really what it means is that the ratio of the measures of the corresponding sides, so when we make fractions out of the corresponding sides, that those fractions are going to be equal. Fractions are equal. Okay, so this is really what you want to be thinking. And once we've proved triangles are similar, we also know that the corresponding angles of the triangles are congruent. So the ratios of the sides are equal. The corresponding angles are congruent. So let's take a look at an example. So we're given right away that we know that the two triangles are similar. So let's get our given information in there. Triangle ABC is similar to triangle FED. That's given. And number 2. So now that we know that these are similar, from the similar triangles we can get ratios. We can't get products, but we can get proportions. And I know that I'm working with BA and ED and BC. That's not BC. This one's BC and EF. So I can see the sides that I want to use in my proportion, and I just need to write those out. So I'm going to write a proportion of the corresponding sides. So I've got BA to EF, so those are corresponding sides, is going to be equal to BC to ED. So notice how on the top I have sides from the triangle on the left, and on the bottom I have sides from the triangle on the right. So I go side on the left over side on the right equals side on the right over side on the left. Now there's lots of other ways that you could write this. You just need to make sure that it's in a corresponding manner. Okay, so for this our reason is if triangles are similar, then their corresponding sides are proportional. Proportional. Alright, and then from here, I can see if I cross multiply, I'm going to get what I want to prove over here. So I've got BA, cross multiplying BA times ED is equal to BC times EF. What I ended up with in step 3 are products. I have a product on the left side of the equal sign and a product on the right side of the equal sign. So we know that that's going to be my means, extremes, products theorem. Okay? You use the theorem that matches what you end up with. So I ended up with products, so I use the product theorem. Alright, so that's our first example. As always, write down questions. Make sure you ask me in class. Moving on to example 2. So we're given that QT is parallel to RS, and we want to prove PQ over RS, so that's this side over here, is equal to PR, so that's this whole side over here, over QT, this side over here. Alright, so we can see the sides we're working with. We probably are looking at triangle PQT and triangle PRT, and if I can get those similar, then I can work on getting these products that I want here. So since we're given parallel lines most of the time we use to get angles congruent. So I'm going to put a 1 and a 2 and a 3 and a 4. And like we saw in the previous section, angle P is part of both triangles, but I'm going to use the corresponding angles on the left and on the right just because it's a little bit less to write, but really that's the only reason. So since these are parallel, I know that angle 1 is congruent to angle 2. Parallel lines implies corresponding angles congruent. And then I've got angle 3 congruent to angle 4 for the same reason, so same as 2. And now that I have two pair of angles congruent in the triangles, I know that the triangles are similar. So triangle PQT is similar to triangle PRT by angle similarity. Don't forget the steps that you have your congruent angles. And now that I have these triangles congruent, I want to look at some proportions that use the sides that we're working with. So I'm going to do the ratio of PQ to PR. So that's the side on the left of the little triangle to the side on the left of the big triangle. So I've got PQ to PR. And then I'm going to do the bottom side of the small triangle over the bottom side of the big triangle. So that's QT over RS. If triangles are similar, then their corresponding sides are proportional. And now again, I can see that if I cross multiply, I use my means extremes products theorem, that I will be able to prove what we need to up here. So now I'm going to cross multiply, so PQ times RS. PQ times RS is going to be equal to PR times QT. And this is our means extremes products theorem. Okay, so products here has to match with products here. Make sure that you do that. All right, moving on to our last example. So we're given that DE is parallel to AB, and I'm given that EF is parallel to AC. And I want to prove that CD, so I'm just going to highlight these for this one, CD over DE is equal to EF to FB. Okay, so I see that I have these two triangles in the left corner and the right corner, and if I can get those similar, then I can do this by getting corresponding parts proportional. So let's get our given information in here. So I've got DE is parallel to AB, and I've got EF parallel to AC. These are both given. And I'm going to put a 1 here. And I'm going to put a 2 over here. And then I'm going to put a 3 and a 4. So we can see that, let's see what I've got. These are parallel. So I know that 3 and 4 are going to be congruent. Angle 3 is congruent to angle 4. Those are corresponding angles. Corresponding, flip that around. Parallel lines implies corresponding angles congruent. So now I've got these congruent. 3 and 4. And then I can see that 1 and 2 are also corresponding angles for, so here's this side and this side, those are parallel. And then this would be my transversal. So there's my F, so I know that 1 and 2 are also going to be congruent. Angle 1 is congruent to angle 2. And that's for the same reason as 3, same as 3. Those are corresponding angles, so parallel lines implies corresponding angles congruent. And that gives me enough to say that triangle CDE is similar to triangle EFB by angle similarity, and I have that in steps 3 and 4. Those are my congruent angles. And now that I have those triangles congruent, I can look at, let's see, some proportions. So remember I mentioned as long as you're consistent with naming your proportions, it really doesn't matter how you do it. So even though CD and DE are the same sides of the triangle on the left, if I want to write the ratio of CD to DE, then I need to make sure I do the corresponding ratio for the other triangle. So I did long side on the left to short side on the right. So then in my other ratio, I want to do long side on the left to short side on the right, which would be EF to FB. So this is a perfectly acceptable proportion from the similar triangles. You just need to make sure that you name the ratios consistently. So if triangles are similar, then corresponding sides are proportional. Alright, so there's 3 examples for you. Again, if you have any questions, make sure that you ask me in class, and we will see you next time.